Hello, I'm Christelle Castet, climatologist at AXA Climate. Today, I'm pleased to introduce you to Professor Carlos Pérez García-Pando, who is a brilliant researcher, member of the community of the AXA Research Fund. You are an expert on sand and dust storms, and your work aims at better understanding, predicting, and managing the impact of sand and dust storms. Is that correct?
Exactly, that's who I am.
Perfect. Maybe we can start also by explaining the difference between sand and dust storm. Are they different? What's the difference between the two?
Well, I mean, that's a really interesting question. So there's no clear definition, and in fact, always a dust storm, like in general, has to be preceded by a sandstorm. So, and this is related to the way dust particles are emitted typically from desert areas. In fact, in order to produce dust, which is the finest material, like we're talking about like tens of microns in size, you need the very large particles to be emitted as well, because how dust or like the very fine particles are emitted is not by direct emission by wind, but it's typically through what we call sandblasting. So there's saltation, so the larger particles with wind start to move and to hop and to jump, and then they strike upon the surface and they release the fine dust. Okay, so typically a sandstorm it's used to define like an event over of course sandy areas where it generates a lot of coarse material. A dust storm, like it generates large amounts of dust particles, which are the finer ones that are traveling also very much far away, like compared to the sand ones. And sand and dust storms it's a way we have to name the family of storms, of course.
I see what you mean. And speaking about area affected, what are the geography impacted by these sand and dust storms?
Okay, so I mean, all the continents have like dust storms. I mean, the largest region for emission, the two largest regions are Northern Africa and the Middle East. But there are also like important sources in Central Asia. Also, I mean, there's regional activity in other basins in the US, in South America, and South Africa, and Australia. About half of the global dust comes from Northern Africa. And again, then the Middle East. So it's very important in the Northern Hemisphere, less important in the Southern Hemisphere. But even if there's less amount in the Southern Hemisphere, it has important impacts, for example, on ocean productivity at different time scales.
There is also fewer land in the Southern Hemisphere.
Yes, absolutely. Less land and less arid land, yes.
Yeah, both, arid land. Australia, you mentioned, is also an area where you have lots of sand.
Yeah, there are a lot of sand dust storms, and they're in combination with wildfires. I mean, sometimes they make a lot of impacts on different aspects of the climate, they impact the ocean as well, but also economic activity and health.
Yes, talking about health, we've seen in the media recently that lots of sand and dust storms occurred in the Middle East, maybe over 10. In Iraq, many people went to the hospital, thousands of people. Can you tell us more about the origin of these events?
So what has happened in the Middle East, particularly in Iraq, is a combination of factors. The first one is that there's a extended drought in the region, and there are anomalies in vegetation. We can see from satellite data compared to previous years how the amount of vegetation has decreased, so the vegetation cover has decreased. That's the first factor, particularly in the Fertile Crescent. Then the second factor is that there has been certainly a degradation of the land over the last years for many reasons, economic reasons, conflict, combination with drought. Misuse of water for irrigation and agriculture. So there are a lot of anthropogenic factors going on in the region. And then the third component, which is what I started with, like the wind. You need the wind. Even if you have those conditions, you need the wind in order to have that storm. So if we have had like an increase in the frequency of dust storms, it means that the episodes of high wind have increased. We know, like from previous research, that La Niña phase, in which we are now, With the La Niña phase, there are more like winds, like northwestern winds, like what we call the Shamal winds affecting the region, that start early in the season. Typically, they are like prevalent in the summer, and this has happened like they were there early on. So this could explain partly the anomaly, together with the other ingredients, on why we're seeing all those dust events. Okay, like the last factor, which I forgot, is like on top of this natural kind of variability or drought, you have like the fingerprint of climate change, of course, which can make droughts even worse. And this is probably what we're seeing in the area.
And talking about climate change, we know that some dry area are going to become even drier, and I'm thinking of the Mediterranean area that is close to us. Could we see an expansion of this favorable condition to dust and sandstorm in this new geographies a bit more
Absolutely,
north?
absolutely, yeah? Totally. And one candidate, for example, is Spain, the southern Spain. The projections of dryness towards the end of the century, they are like under certain scenarios of climate change, of global warming. They are really quite impressive, so the southern Spain is greatly affected by dryness, like under the next century, and in fact we're already seeing this year and last year there were, as you know, like very strong dust events affecting Europe. Like there were particularly two. One that affected Europe this year, like reaching up to France and affecting the Pyrenees and the Alps. And greatly affecting Spain, like the concentrations reached 7 times more than in the previous records. So that was like an absolute record for the region for dust. And same happened 2 years ago. And in fact, also 2-3 years ago, there was another event in the Canary Islands which was like breaking records as well. Okay, so out of 3 years, we cannot say much about the trends. But what we know, what is happening, is that there's an extended drought in the northern tip of North Africa, like affecting Morocco, affecting Algeria, and other countries. And this could be on the basis of these events. We're still studying that, but definitely we're having these decadal variations in climate. But on top of that, we have global warming, which could be affecting certain areas, and we think that is what is happening. Yeah.
And talking about trends, I know you're a co-author of the IPCC report that came out last August. I think chapter 10 on regional scale climate modeling. What are the impacts of climate change on the trends of dust and sandstorms? Are they becoming more intense, a bit more severe? Reaching new geographies, as we already talked about?
So I contributed to 2 chapters, chapter 10 and chapter 12, on dust aspects. So the projections of dust are very uncertain. That's the first thing I have to say. Basically because dust storms depend on a myriad factors, and some of them are currently not included or not taken into account into climate models. And I could name a few. For example, many climate models still do not have a dynamic vegetation model that reacts to global warming, and by which we could have more or less dust storms because there's a decrease or an increase of vegetation in a certain area. Climate models do not include the effect of cultivation directly, or land management in cultivation into dust.
Human activity.
Yeah. So that is another uncertainty, for example. But also we do not know very well how wind is going to be like by the end of the century. We have some evidence, and this is happening over the last year, that in some regions, important regions, for example, North Africa, the average wind is being reduced. So that would mean less wind, less dust. Okay. So, and this is what we are seeing on average from Northern Africa in the last years. But we have a lot of uncertainty into the extreme episodes. What's going to happen with them? Those that create more dust.
What are they related to, these extreme events, storms?
So, like, there are the extreme events. Okay, the first ingredient, as I said, extreme event is high winds. And, whatever meteorological scenario produces high winds, it's going to create a huge dust storm whenever it touches like a source with an erodible surface. So you can have different meteorological scenarios, but if I can like summarize into two, it's like this kind of synoptic scale storms, which are, you know, depressions, for example, that you know, occupy a very wide areas with very high winds, like frontal systems. Then you have like the mesoscale, more like convective events, which are very short-lived, but
Those
very,
are
very
big
powerful.
thunderstorms that create these walls of sand that we can see in.
Exactly.
Okay.
So they are much more difficult to predict because of current model technology, and
they're very local.
it's very local. So you need to have a very good characterization of the precise location of the sources, which is like, you know, not always the case, and you need to really be able to know where this like small scale storm is going to happen, which is a challenge for meteorological models. So depending on the climate scenario, like some models are predicting you know, more convection or less convection. And so there's a big uncertainty there. So just to respond to your question very precisely with what we know. So we know that in some areas, the conditions for dust are gonna, like prone for dust, are gonna be worse. Like for example, in the Middle East, you know, like the projections there in terms of warming are very concerning. And if winds do not change much, we are likely going to see like an increase in dust storms over there. In the US, for example, predictions are also towards drying in the southwest and towards more dust. And this is, you know, there's a certain certainty there. Northern Africa is more uncertain. There's a, you know, probably a decrease in the general circulation, so like a decrease in winds, but, you know, we don't know much about the extreme events. And there are other regions where uncertainty is very high, although in Australia it's likely going to increase as well. So,
lots of things we don't know, but some things we know.
Yeah,
and
exactly.
So what impacts the sandstorms is, from what I understand, the droughts that can create dry land. There is also the winds, and there is also this idea of a source of emission. And you work a lot about characterizing these sources of emission. How is your work progressing in that regard?
Having the opportunity, I'm a modeler, I'm a theoretician, a modeler, and with a project that started in 2018 called FRAGMENT, that is also, of course, co-funded by AXA, but it's an ERC grant from the European Union. I was given the opportunity to go to different deserts of the Earth and implement measurement campaigns in order to study dust emission and to understand like better the physical processes that are related to the emission of dust. In particular, what we're studying is how these particles are emitted in terms of their size distribution and their composition. Okay. And why this is important? Because the size and the composition is going to ultimately determine the effects of these particles on the climate. So one aspect of my research is to understand variability of dust, but another aspect is to understand how dust modifies the climate, which is another important piece of the puzzle. Okay, so we still don't know, like globally, you know, if dust is cooling or warming the planet. I mean, this is a fundamental question.
Sometimes we think of dust as volcanic ashes that reflect the sunlight and therefore kind of cool our Earth, but it's not only the case. You say that there are also factors or particles in the sand and the dust that can absorb the heat as well?
Yes, well, you have like, first of all, like the size distribution of dust is very wide. So we have like very fine particles and very coarse particles. Depending on the size, particles tend to cool or warm. Because, you know, like depending on their size, they're going to reflect differently, like the short wave or the long wave radiation. But then also, one of the key questions of climate change, you know, modeling is to understand how clouds are going to react under a warming climate. And in this puzzle, dust affecting ice clouds is a big unknown, and, you know, we're working in that direction to understand better these things. So, but for that, so we need to include mineralogy in models. So, like, dust is composed by many different minerals, have different properties that affect differently the climate. And, you know, this is what we're doing in FRAGMENT. So we're trying to understand better like put this information, like better theory in our models and better data in our models. And this is connected to another project that is called EMIT. That it's a NASA mission in which I'm involved, and there the plan is, in fact, in a few weeks from now, there's an instrument that is going to be deployed in the International Space Station.
So this NASA mission will aim at understanding what the soil is made out at a 60-meter resolution in many geographies. Those are huge challenges regarding data and storage and
Absolutely, that's a big data set that's going to be generated. So like this NASA mission like intends to get this data set, which is already like a big piece of the project. But then, so this information is going to be introduced in different models. To understand how these particles affect the climate. So climate models need this kind of boundary information of the soil on how like the soils, what is the composition of the soils. So when the particles are generated in the model, they're going to have the mineralogy of the soils. And this is where also FRAGMENT comes in, like the project in which we measure across the different desert areas, is to understand how these minerals are emitted and what is their size distribution. So with the two types of information and of knowledge, the idea is that we improve how like climate models work, and in particular like how like dust is affecting our climate.
So you just are telling us that climate change is impacting dust storms, but dust storms are also impacting climate change. There is sort of a loop here.
Absolutely.
It's a great project. Congratulations. Yes. I wanted to discuss impacts, especially impacts on health or impact on our everyday life of these events. What can you tell us about the impacts of these storms on us?
The dust storms can generate disproportionate amounts of dust in a certain location, which disrupts certain socio-economic sectors, even life as we know it. I mean, not in Europe, because in Europe we are a scepter region, but in areas that are close to sources, the amount of dust is really very high, and when they have like strong events, they can disrupt daily life like very, very strongly. One example is health, but not only. I mean, health is one of the aspects. Transportation. Visibility is reduced to a few meters. So like there can be car accidents, there are, like people need to stop driving, closure of airports and disruption of operations. It can affect like dust particles, strong dust storms can affect communications, like communication systems. But then also there are other sectors that are promising in those regions, which is, for example, solar energy production, that are affected by dust, by reducing the sunlight and also by being deposited in the solar panels. So understanding, predicting these storms is essential for mitigation. Mitigation meaning planning.
Especially these solar panels are often installed in an area where there is lots of sunlight, and so probably areas where we have lots of this kind of events.
Sure.
So you have to quantify, understand.
There are certain ways of preventing dust emission, like particularly in areas that have been anthropogenically perturbed. You can like take measures to reforest, to better manage the soil, to better manage the water. So like you create, like you do mitigation of the sources, let's put it this way, but that's not gonna solve entirely the problem. And there are many natural areas that are affecting different countries, and they are really impossible to control, and it's not desirable to control them. I mean, we cannot do that. It's a natural cycle.
Because there is some positive impact on agriculture, for instance, sometimes? It depends on the quantity.
It depends on the quantity, of course. But dust particles fertilize the ocean and fertilize like forests as far as the Amazon. Okay, they are transported there, and they fertilize with nutrients, including phosphorus. So it's part of the natural cycle. But of course, we can make it worse, and we can also, act to prevent certain dust emissions from happening with windbreaks, again, reforestation and other measures. But there's a large part of the dust that you're not going to avoid. So what you can do, particularly for the impacts that are not desired, like the negative impacts, particularly close to the sources. You want to have like early warning systems connected to other to mitigation plans, like short-term mitigation plans, meaning what does certain sector do when there's a dust storm? Like for example, in terms of perturbation of airports and flights, etc. There can be increased preparedness
So talking about adaptation, those are tools that are helping take action before the event arrives, is predicting these sandstorms. Right?
Absolutely, yeah. Absolutely. For example, in terms of health, there are many areas where effective action could be taken. For example, like we know that when there are big dust storms, like the one in Iraq, there are going to be more hospital visits. Mm-hmm. So already that information for the medical doctors, for the hospitals, is already an information they can use to prepare. That's one example.
Aviation is another one.
Aviation is another one. Solar energy production is another one. Eventually agriculture, planning on planting or collecting crops.
What are the tools available to predict these storms?
So I can say that now that there's a reasonable amount of information that can be already accessed by the general public, by administrations, by others, both in numerical format or in more qualitative format, to understand where there's going to be a dust storm. Of course, there are many uncertainties. For example, like these kind of episodes in which we have like the haboob. Mm-hmm. They're very difficult to predict. But
what is haboob? It's
haboob
a
is
big,
like the mesoscale
right?
storm. Yeah, yes. So the information is out there, but it's not like what we need now. In my opinion, is to connect that information to impact models. For example, solar energy production. There are operational maintenance models that take into account different types of information to finally take certain decisions. So inserting dust predictions into these models properly, so the operational maintenance model can optimize the operations, and in fact the final outcome is going to be economic. There are opportunities there for the industry and for preparedness that, particularly in these countries that are going to see an evolution in Northern Africa over the next century.
Great. And is there any knowledge gap that we still need to fill to improve these predictions or quantify the impact? Yes.
Yeah, a lot.
There's still a lot of work ahead.
I see enormous gaps. So, as I said, progress has been important in the last few years, and we have certain capabilities, but there are a lot of uncertainties still in these forecasts, particularly with some of the most important storms that can affect population, which are these short-lived storms that can be very, very... So that's a very hard problem. We need also better observations over these areas to improve the models, because models need to be initialized, and typically the initialization of these models over those areas is not the best, because there is a lack of observations. Mm-hmm. So in this case, satellite observations are playing an increasing role, and we will see progress in this in the future. So that's for forecast technology. Then extending also the range of our forecast. Now we're having forecasts up to 5 days. There's a gap in, for example, subseasonal and seasonal forecasts. I think it's possible, it should be possible to have some information at those scales that is currently not available. So yeah, there's a bunch of aspects in prediction. And then, of course, for the impacts, there's a lot of gaps into understanding the impacts of dust in different socioeconomic sectors. We're working on health, we're working on solar energy production, we're working on transportation, but there are many other sectors that will need attention, and we plan to tackle it in the chair, which is, for example, agriculture. There's not much done in that respect. So.
Indeed, in order to take action, you need to quantify the impact so that people, society can react. I know that the COP15 to combat desertification took place maybe 10 days ago in Abidjan. There wasn't much media coverage from it. Is that because of a lack of maybe also knowledge or maybe interest on this topic? So what do you feel could be the cause of this?
when it tackles specifically the certification, there's less broad interest of the community. That's what I would say. But I think, I think it's interesting because UNCCD has started to really tackle sun and dust storms. In fact, one member of the chair is part of the panel that is dealing with that. So it's very important to have this communication with the countries. When we think about mitigation, like short-term mitigation can be done like planning what to do once the dust storm is predicted, right? The other one is, as I said before, like how we reduce dust storms in certain places. And for that this is long-term policy investments. That science, that the best science is applied to like specific regions, how to manage the water. There are political issues around water. There are political issues around land management. There's political instability that is affecting the long-term stability of a certain policy, right? So there are many challenges, so UNCCD is an institution that can and has like these connections with the countries and with the people working directly on these issues of land management. I think it's an important aspect to that this is happening, in fact. Yeah.
So let's maybe finish with this note on land management and better understanding this impact of sand and dust storms. Do you have some concluding remarks on what we can do maybe today to adapt or mitigate some impacts?
I think there are two types of actions that we can do. The first one, again, it's increasingly rely on dust forecasts and use them for mitigate or to reduce the negative impacts of dust storms. The second, in what it refers to mitigating the sources of dust storms, I think there are possibilities in certain areas, and there are some kind of experiences that have been positive, for example, in East Asia, in China, where reforestation, there's some evidence that it has worked in certain areas. So I believe these experiences could be applied to certain regions.
And reforestation has this positive impact that it also captures carbon dioxide,
exactly.
So in mitigation of global warming too. You have to think of this system as being integrated, I guess land, climate, human society,
Absolutely.
biodiversity all together.
Absolutely. And the other big issue is water. So like the use of water in these areas for irrigation, for example, and agriculture. There's a bunch of lakes that have dried out in certain regions, for example, in the Middle East. Partly due to drought, partly due to global warming, like natural drought, global warming, like anthropogenic, but also due to water irrigation for agriculture. And when these lakes dry out, they are super emissive dust sources. So it's an integrated policies of land use, water, agriculture are very important. And reinforcing the short-term aspects of mitigation. Like if you cannot mitigate on the short term, use better the forecasting technology available to inform your population, to enforce new mitigation plans on the daily basis. So
great. Well, thank you so much, Carlos, for enlightening us on these different topics around sand and dust storms. I found it personally very interesting, and I'm wishing you all the best in your projects.
Thank you very much.
Thank you.
Thank you.
And I wanted to thank everyone for listening. You can find more information on this project and many more on the AXA Research Fund website.